All right. Part 2 of chapter 3, section 2. Talked about part 1 yesterday, correct? Raise your hand if you can tell me what makes a linear function linear.
It's a line.
It's a line. Very good. The graph of it's a line.
It has no repeating y decimals or x.
That's to tell if it's a function or not a function. I'm just saying what makes it linear.
Constant rate of change.
Constant rate of change or a constant slope. And was there one more thing?
Vertical line test?
No.
No, you only tell me
No, there's 3. What if it's an equation? If I can write the equation in y equals mx plus b form, then I know it's also linear. Okay? Yes?
Isn't that equation called subintercept form?
Yes, it is. So that's the 3 ways we tell if it's linear or nonlinear, correct? Depending on what we're given. If we're given a graph, we look at the graph. If we're given a table of values, we look at the rate of change. If we're given an equation, we try to get it in slope-intercept form, y equals mx plus b. Are there any questions from yesterday's notes? Or did we all understand that pretty well? Okay. So here's just some different representations of functions. Is a function a relation? Yeah, it is. A function is just a special type of relation. Right? It's a relation in which none of the x values repeat. So, these are the ways I represented my relations back whenever we took our notes over relations, correct? So, since a function is a relation, it can be expressed the same ways that a relation is expressed or represented. So I can use a table of values, input-output table. I can use a mapping diagram, or I could use a graph to represent my functions. Because they are relations, right? So here, I'm given the equation y equals x plus 3. So I get some x values in my input-output table. And I'm plugging those values into my equation to get my outputs. So I plug negative 1 in. Negative 1 plus 3 gives me a y value of 2. Plug 0 in. 0 plus 3 gives me a y value of 3. Plug 1 in. 1 plus 3 gives me a y value of 4. Plug 2 in. 2 plus 3 gives me a y value of 5. So everyone see that? That's how our input-output tables work. I can create my mapping diagram for my ordered pairs. Negative 1 maps to 2. 0 maps to 3. 1 maps to 4. 2 maps to 5. And then I can just graph all those ordered pairs to get a graph. Questions on any of those representations? Can I move on?
Nope.
Perfect. Did you say nope?
Yeah.
Okay, I'll wait a little bit. I can always come back to a slide if I need to. Okay, moving on. A solution of a linear equation in 2 variables is what we call an ordered pair. You guys have heard of an ordered pair, correct, before? An ordered pair, x comma y, that makes the equation true. So for an ordered pair to be a solution to an equation, I have to be able to plug both the x value and the y value in, and it has to make the equation true. That's what it means for it to be a solution of that equation. The graph of a linear equation in 2 variables is the set of points x, y in a coordinate plane that represents all solutions of the equation. So my graph, when I graph a line, represents all solutions of that equation that I graphed. Does that make sense? Every point on that line is a solution to that equation. Sometimes the points are distinct, and other times the points are connected. We kind of talked about this a little bit a few days ago when we did our domain and range. You guys remember when we had those curves? And we had to use an inequality to represent my domain and range because there were so many numbers on that curve that I couldn't just list them all, correct? But when the points were disconnected, they were distinct points, all on my graph, I could just list the x and y values, correct? Okay, we have two words for that. Those two words are on the next slide. So one of them means that the points are distinct, and one of them means that the other points are connected. And we'll get to that slide here in just a second whenever we're all done writing. We good to move on? Okay, those two words are called discrete and continuous. A discrete domain is a set of input values that consists of only certain numbers in an interval. So there's a set amount of points. Okay? The points are not connected. I cannot include points between those 2 points. So here, an example would be the integers from 1 to 5. The set of integers does not include any fractions or decimals. It's only the whole numbers. So if I want the set of integers from 1 to 5, I only have a point on 1, a point on 2, a point on 3, a point on 4, a point on 5, because those are the integers. No numbers between these numbers count as integers, because they're decimals or fractions. So there's only some specific numbers for that domain. So that would be called discrete. Does that make sense? Ish. A continuous domain is a set of input values that consists of all numbers in an interval. So instead of the integers from 1 to 5, I want all numbers from 1 to 5. That includes decimals, fractions, all that good stuff. So those 2 points on the end are connected with a line instead of just putting points on the whole numbers. Because I can include all the numbers between 1 and 2 now. I can include all the numbers between 2 and 3, 3 and 4, 4 and 5. That line just represents all the solutions to that set. Does that make sense? So continuous means that they're representing all the numbers on that interval. Discrete means it only consists of certain numbers. Okay? Any questions about discrete or continuous? We still writing? Okay, I'm waiting. Good to move on? Nope, waiting a little longer. A few more seconds. Ten more seconds. Okay, moving on. Here's our first example for today. The linear function y equals 15.95x represents the cost y in dollars of x tickets for a museum. Each customer can buy a maximum of 4 tickets. Letter A wants us to find the domain of the function, and then it wants us to tell if the domain is discrete or continuous and to explain. Part B says graph the function using its domain. So I've got to find the domain of my function first. Is my domain my set of x values or my set of y values? Set of my x values, right? What is my x representing in this case? Tickets, right? Y is representing the cost. X is representing the number of tickets for a certain person. It says each customer can buy a maximum of 4 tickets. So does anyone have any ideas of what my domain is going to be? Wait, hold on. Yes.
1, 2, 3, 4.
1, 2, 3, 4. Is that it?
Yes. Because they can buy maximum of only 4 tickets.
They can buy a maximum of 4, so I have to stop at 4, right? So do I need to use an interval or anything like that? Like an inequality to represent that interval? Or why not?
Because it's like, I don't know.
Well, can you buy half of a ticket?
No.
No. Can you buy 3/4 of a ticket?
No.
Can you buy a third of a ticket?
No.
Can you buy 1/6 of a ticket?
No.
Can you buy 99/100ths of a ticket? No. You can only buy 1 whole ticket, 2 whole tickets, 3 whole tickets, 4 whole tickets, etc. Well, I can't go past 4, can I?
Nope.
Can I buy a negative number of tickets? Nope. Can I buy 0 tickets? Yeah, I don't have to buy any tickets, do I? So what numbers are included in my domain? Is that it? That's it. There's my domain. Does that make sense on why that is my domain? Because that's the maximum amount of tickets I can buy is 4, so I have to stop there. My minimum amount of tickets I can buy is 0. And I can't buy any fractions of any types of tickets, can I? So it has to be 0, 1, 2, 3, or 4 for my domain. Everyone good with my domain?
Yep.
Okay. Is this domain discrete or continuous?
Discrete,
Discrete. Why is it discrete?
because
There's
it's
only
only whole
a.
numbers.
It's only a set number of x values, correct? Because you can't buy fractions of tickets. So we would say this is discrete. Because you can't buy fractions of tickets. Does that make sense for letter A?
Yep.
Boom, we've answered number A, or letter A. Now we got to do letter B. Graph the function using its domain. How do you think I'm going to graph this using my x values?
The what?
How do you think I'm going to graph this using my x values, my domain?
From the x-axis?
Huh?
Graph on the x-axis?
Well, I've got a y-axis, right? It gives me y value.
I think I'd put those in too.
Yeah.
Do we plug it into the equation?
Plug what into the equation?
The X value.
Very good. It gives me an equation, right? A linear function. Y equals 15.95x. So if I have x values but not y values, to get my y values, I can just plug these in for x. Right? There's my graph. So I'm just going to make an input-output table. We already know our x values are 1, 2, 0, 1, 2, 3, and 4. And we know our equation is y equals 15.95x. Correct? So I'm going to take turns plugging my x values in. Plug 0 in first. What's 15.95 times 0? 0. So when my x value is 0, what do I get for my y value? 0. Does everyone see how the input-output table works? Have you guys dealt with input-output tables before?
Yes.
Okay, good. Hopefully some of you have. If you haven't, does it make sense?
Yes.
Okay. Now I've got to plug 1 in to get my y value for 1. What's 15.95 times 1? 15.95. What's 15.95 times 2? 31.9. What's 15.95 times 3? 47.85. And then lastly, what's 15.95 times 4? 63.8. So there's my ordered pairs that I'm going to graph on my graph. Okay? My y-axis only goes up to 10, so I'm going to adjust it a little bit. I'm going to make it go up by 10s. So I've got 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Everyone okay with that?
Yep.
Understand why I adjusted my y-axis. Okay, my first ordered pair is 0, 0. What do we call the middle of the graph? Starts with an O.
Origin?
Origin. Not Oregon. Origin. Ha!
Good save.
That was funny. Okay, 1 comma 15.95. I'm going to go right 1, up 15.95. I'm going to go with that. 2 comma 31.9. I'm going to go right 2, up 31.9. 3 comma 47.85. Right 3, up 47.85. And then 4, 63.8. Right 4, up 63.8. Everyone okay with how I graph them ordered pairs?
Yeah.
Everyone knows how to graph an ordered pair. Okay. Do I connect my points here?
No.
Why?
Because they're not,
It's discrete, right? It's a discrete domain, so I cannot connect my points. If I connected my points, that'd be saying every point on the line would be a solution of my scenario, my equation, right? But this number right here, it would be on the line, right? But that number is between 1 and 2. Can't buy 1.5 tickets, can I? So I cannot connect my points here with a line. They have to stay just like this. Okay? And now, have I answered everything the question wanted? Yes, I have. I told the domain of the function, I told if it was discrete or continuous, and I explained. Then I graphed the function using its domain. Questions on this example? Did that make sense? Can I erase my graph and move on to my next example? Yes. What? Don't worry about it. I'm just kidding. 6. Next example. A cereal bar contains 130 calories. The number C of calories consumed is a function of the number B of bars eaten. You got 3 parts here. A, does the situation represent a linear function? Explain. B, find the domain of the function. Is the domain discrete or continuous? Explain. C, graph the function using its domain. So letter A. Does the situation represent a linear function? Explain. Is this going to be linear or nonlinear, and why?
I'll say non-linear
Why?
because, like, I'm trying to think. I guess it could be.
Huh?
I don't know what I'm saying.
Okay. Anyone else have any thoughts? I'm not saying Ryan's right. I'm not saying Ryan's wrong. I'm just needing an explanation with it. Linear or nonlinear? Think about how we tell if something's linear or nonlinear.
the constant rate of change.
Ah, okay.
What?
What'd you say?
I said constant rate of change.
What about a constant rate of change?
I don't know.
Got it.
Yes?
It's going to be non-linear because it's not going to have like a constant rate of change.
It's not?
No.
Are you sure?
Because it's like a cereal bar, you can eat like a quarter of a cereal bar and then eat like.
We're not talking about discrete or continuous yet.
I know, but
Okay.
I'm saying that like how much you eat depends on you.
Okay. Let's think about it real quick. Let's think about our rate of change here. Our rate of change is our change in y over our change in x. We don't have x and y here yet, but we can see if both of them are increasing or decreasing at a constant rate. Okay? If I eat 0 cereal bars, how many calories have I consumed? 0. Okay? If I eat 1 cereal bar, how many calories have I consumed? 130. If I eat 2 cereal bars, how many calories have I consumed? 260. If I eat 3 cereal bars, how many calories have I consumed? 390. Are those values increasing at a constant rate?
Yeah.
They are.
But
So, is it linear or nonlinear? Linear. You're saying if I eat 1.5 candy bars or cereal bars, that it would not be a constant rate. It would still be a constant rate. Because if I eat a half a cereal bar, I'd be consuming 65 calories, right? That's still a constant rate. Because instead of going up 1 and over 130, I'm going up half and over 65.
But if you eat,
It's still on that line that makes the line.
65.
yes,
Right.
Let's say you eat like 1/4 of a candy bar.
Okay.
And then eat rest of it, like 3/4 of the candy bar.
Then you've eaten one whole candy bar,
Yeah. One.
right?
But like, it's in like a different set.
You're still eating one cereal bar.
Yeah, he's talking about like how you would eat one, then you would eat again, then you would eat again. Like you would eat the same candy bar, 1/4, 2/4, 3/4,
Right. You'd
4/4.
keep going up till you got to
Yeah,
one.
that's what I'm saying.
It's still going up at a constant rate, right?
Yeah.
Because if you eat 1/4 of the cereal bar, you're not consuming 130 calories, are you?
No.
No. You're consuming 1/4 of those calories. So it's still a constant rate. Does that make sense?
Yeah.
Maybe it'll make more sense once we see the graph, because we are going to graph it. Okay? So this is linear. Does everyone see how it is a constant rate of change, though?
Yeah.
Okay. So it's linear because it has a constant rate of change. Questions on letter A? We've answered letter A. It's linear, it's got a constant rate of change. Okay, letter B. Find the domain of the function. Is the domain discrete or continuous? Explain. So let's find the domain. Do I have x and y here?
No.
What variables am I using?
C and B.
C and B. Number C of calories consumed, C stands for calories consumed, is a function of the number B of bars eaten. B stands for number of bars eaten.
So
Okay? Is my x variable always the independent or dependent variable?
Independent.
Independent. Y depends on x, right? So x is the independent variable.
Yeah.
So which one of these is going to be my independent variable and take the place of x?
B.
B.
Bars eaten.
Oh,
C.
C takes place because how many bars you eat.
So yeah, it is B bars, right?
Yeah.
Because like we said, the number of calories I consume depends on how many bars I've eaten. So the number of bars eaten is my independent variable. So my domain is my set of all real numbers B, such that what's my domain going to be?
C.
Hmm?
Was it
Oh,
C?
wait.
C?
Hmm?
Because you said C was.
C is dependent,
Oh, so it's B.
right? Well, I'm saying what's my domain going to be in general now. I know we're dealing with B for my domain.
We're going to have to make it a compound inequality.
It's going to be 1 on 130. 130 is the calories. That's my dependent variable.
It would be like, it would be a compound inequality,
It may not necessarily always be a compound inequality.
but
I do have to use an inequality here to represent all my B values,
so X has to be,
not X.
oh, B has to be greater than or equal to, oh, yeah, B has to be greater than or equal to like 130
Now 130, that's my calories.
or
Calories are my dependent variable,
1.
not 1.
B.
Yeah.
Can I eat negative number of bars?
No.
No. Can I eat half a bar?
Those is zeros.
Yes.
Can I eat 3/4 of a bar?
Yeah.
Can I eat 99 100ths of a bar?
Yeah.
Can I eat 0 bars?
Yes.
So it, B,
B is
greater than
0.
There we go.
Take my mojo,
Man.
B is greater than or equal to 0. Can't have any negative numbers, can we, for B? But I can have any number that is greater than 0 or equal to 0, correct? I can eat 0.1693471 of a bar, right? So it's any number that's greater than 0 or equal to 0. Everyone see that from my domain?
Yes.
So would this be discrete or continuous?
Continuing.
Continuous, because we can eat fractions of bars. Is everyone okay if I do not put the explanation?
Yep.
I would have put continuous because you can eat fractions of bars. That's what I would have put, of cereal bars. So I know I've got to include all those numbers on my interval. Does that make sense for B?
Yep.
Okay. Letter C. Graph the function using its domain. Oops. Graph the function using its domain. What's my first x value?
0.
Let's just go up by ones.
Oh, okay.
Am I supposed to stop at 4?
No.
No, but I'm not going to list them all because that would take me forever.
Yeah.
So I'm going to stop at 4. I'm going to get 5 points on my graph, and I'll show you what we do to let us know that it's going on forever and ever and ever. Okay? Am I given an equation here?
No.
No. Can I come up with an equation?
Yes.
Yeah. Can anyone tell me what my equation is going to be?
Equals CX. No?
We're not going to have x in there, are we? We're just going to have b and c.
Yeah. B equals C. No.
Not an inequality, an equation. The number of calories I consume equals,
Bars.
The number of bars.
what about the number of bars? Well, how many calories are in a bar? 130b.
Do it.
So the number of calories per bar times the number of bars will give me the total number of calories consumed, correct? So there's my equation. C equals 130b. So if I plug 0 in, if I eat 0 bars, how many calories have I consumed?
0 calories.
0. I don't need to have x, y up here. I need to have b, c. If I eat 1 bar, how many calories have I consumed? Does everyone see where I'm getting these c values from?
Yeah.
If I eat 2 bars, how many calories have I consumed? 3 bars.
390.
4 bars.
420. No. 5.
520.
Yeah.
Right? That's where I'm going to stop. My graph, my y-axis, or my c-axis in this case, is only going up to 10. We got quite a few high numbers, so I'm going to go up by 100s. Everyone okay with that?
Yes, sir.
And see why I'm adjusting my y-axis, or my c-axis.
Nope.
You don't understand?
Oh, yeah, I do.
Okay. Okay, 0, 0. That's my origin again. 1 comma 130. I went right 1 up 130. 2 260. I'm going right 2 up 260. 3 comma 390. I'm going right 3 up 390. 4 520. I'm going right 4 and up 520. Everyone okay with how I've graphed?
Yes.
Do I need to connect my points here?
Yes.
Yes, because it is a continuous domain, right? So when I draw my line, am I letting my line go past the origin?
No.
No, because I can't go into the negatives, can I? Because I can't eat negative bars. Can I go past my last dot?
Yes.
Yes, I can. I want it to go past my last dot because I know it's going on forever and ever. I do need an arrow on the end of my line to also let me know what's going on forever and ever and ever. If you don't put the arrow, you're just saying the graph stops there, but it does not stop there, does it? I can eat however many bars I want. Okay? Does that make sense? So, what we were saying earlier, this is a constant rate of change. Okay? If I go up 50 and over 0.5, that's still a constant rate of change, right? And I'd go up, well, not up 50, but if I went up, let's say 65 and over 0.5, and then up another 65 and over 0.5, I'd get to that point.
But what if you go up 65, 1, and then like up 75? Actually, no.
It's not doing that according to my line, right?
Yeah, but it can do that, right? Because
It would adjust according to whatever number it was. So, if I went up 1/4 of 130, 1/4 of 130 is
25. No.
oops.
It's like 30.
30, 32. 32 points.
It'd be 32.5. So I'd go up 32.5 over 0.25. And if I kept doing that, I would eventually go up to this point. It would just take me there. It would just follow this line. Does that make sense? That's what that line is representing. It's representing all those smaller numbers if I were to eat half a bar, a quarter of a bar, 99/100ths of a bar. That's what that line is representing. Does that make sense? It'll correspond with our slope. It just will look a little different. It'll be the same ratio though. Does that make sense?
Yeah.
Okay. Does that help understand a little better? Okay. Okay, any questions? Did I answer everything that the question wanted me to answer? Oh wait, wrong one. There we go. I answered everything, correct?
Yep.
So I'm done with this problem?
Yep.
Perfect. We ready for the assignment? No. Why not? Huh?
Just please don't do this to us. Like, it's,
Here,
like
so
it's tomorrow's Saturday and,
Listen, buddy, we still have Tuesday and Monday.
for what?
We've got a lot of time.
So here's what I told first and third hour. I told them it's Friday. You got the weekend coming up, so we're gonna get our assignment on Monday in class. That's what I told them. That's not what I'm telling you guys. We're getting the assignment. JK. So we'll get the assignment in class Monday. Does anyone have any questions before I end my recording?
No, sir.